Now let's take a look at example 2. I want to convert this particular point to rectangular coordinates. I know that this is obviously a point that's in polar coordinates because the second item listed in this point is actually given as an angle. So I'm going to go ahead and first try to figure out exactly where this point is located. So if I was to go ahead and let me get that in a slightly better spot. But if I was to go ahead and think about where this point is located, I would be able to say that I first have to rotate to an angle of 210 degrees. Notice that 180 degrees would point me out towards the negative x-axis. So 210 is going to leave me facing somewhere in this direction. Notice that that would actually be a 30-degree angle past the 180 mark. So I would have 180 and then an extra 30. And once I'm staring in that direction, I'm told to take 6 steps. And for the sake of argument, let's just suppose that that lands me right here at this point, that this is my point 6, 210 degrees. So I should recognize right away that this is going to be a polar point, and if I want to find my rectangular coordinates, that is, I'm looking for an x, y coordinate that are going to correspond to this point, I can see a couple things about this immediately. First, I'm in quadrant 3, so my x and my y better be negative numbers. If I get anything other than negatives, that is if I get positives or zeros, I know I computed something wrong. But based on what we saw in the last video and what we have listed up above here, we know that in order to find my x and my y, I can simply just set up this calculation. I can do r times the cosine and r times the sine. So I'll state here that in order to find x, I just have to compute my r times the cosine of my theta. Now, this is going to be 6 times cosine of 210 degrees. Notice that's going to be pretty much the same as the cosine of 30 degrees. I just have to account for the fact that this is going to be negative. So this is actually going to end up as negative root 3 over 2. And if I simplify, that's going to be negative 3 root 3. If I set up now what I would need for my y coordinate, I'm going to have 6 times the sine of 210 degrees. This is going to be equal to 6 times negative a half, and so I get negative 3. So my rectangular coordinates end up being negative 3 root 3, comma, negative 3. So converting points like this should be extremely simple. Now if I take a look at example number 3, I'll see that at first this point that I'm going to attempt to convert might be difficult to determine if it's actually polar or rectangular. Notice that by itself there's nothing giving away here whether this is a polar point or a rectangular point. Of course, if I read the entire sentence that I want to convert this to polar coordinates, I do know that this is supposed to be an x and a y. But by itself, it actually still could have been, if this wasn't here, this could have still been an r and a theta. Remember that theta is an angle and it could be measured in degrees or radians. 6 radians is a measurement, and it could be converted. So make sure that when you go through questions like this, you're not just identifying that, oh, there's no degree symbol here, so obviously I'm going to be obviously this is a x comma y point. I could have just as easily given you a point of like pi comma pi, and that could have been an x and a y point and said convert, right? The only thing that's a dead giveaway on any of these questions as to what you're working with is if you had a degree symbol. Okay, so if I have this now set up as an x comma y point and I want to go ahead and convert it, first I'm going to start by figuring out where I'm at again in terms of my xy axes. Well, I can see that if I go over negative 3 and then I go up 6, this is going to go ahead and give me a point over here. Picture not drawn to scale. Okay, so here's my point negative 3 comma 6, and I know this is a red rectangular point. What I'm going to be looking for is how far did I have to walk out from the origin to get there, and ultimately what angle did I have to rotate in order to stare in that direction. That is, I want a value of theta and I want a value of r. So we saw, based on the previous video, that there's a relationship between my r and my x and my y. Notice that this side of the triangle over here has length 3, this side of the triangle has length 6, and the hypotenuse is that value of r. So I know that 3 squared plus 6 squared has to equal r squared, That, of course, gives me that r squared is going to be equal to, let's see, 36 plus 9 is 45. And that gives me that r here is going to be the square root of 45. Notice I'm not going to deal with the plus or the minus. I'm just dealing with the plus. I'm going to assume that my angle is going to face me in this direction. Of course, if I wanted an angle that pointed me in the opposite direction, then I could use the negative r, and that would be fine. But it seems like now I already have my value of r. I'm good to go on that piece. Now to find my theta. I could again set up a whole bunch of different trig ratios to help me understand what's going on with this angle. So for example, I could say that the tangent of theta is equal to 6 over 3. That is, it's equal to 2. And while that's accurate, I'll realize that if I do the inverse tangent in order to try to find theta, I'm going to have a problem. Because inverse tangent can only find me angles from negative pi over 2 to positive pi over 2. And since theta is not one of those angles, my inverse tangent won't help me here. So instead, I might try to think about a different trig function I might be able to use that can tell me an angle that exists in the second quadrant. Well, one possible choice for that would be something like a cosine. In this case, my cosine would be equal to 3, or in this case, I guess I have a side length there of negative 3. And I could do negative 3 over my hypotenuse, which is that square root of 45. Notice I do have to be careful over here to make sure that I'm inserting this side as negative, since it was moving in a negative direction. Now, if I go ahead and I work with this, I can go and see that I can now use state that my theta is simply the inverse cosine of negative 3 over 45. So I know that this here works out perfectly. So this would be an exact answer. Of course, if I wanted to get an approximation, I'd have to switch over to my calculator. If I switch to my calculator, I could go ahead and say that I'm going to be doing that inverse cosine of, and we said that it was going to be negative 3 divided by the square root of 45. Of course, if I hit enter on this right now, since my calculator is in radian mode, it's going to give me an answer that's in radians. If I want to convert that to degrees, I would have to multiply by 180, and then I would end up dividing by the value of pi. So this would be about 116.6 degrees. That's what I'd be working with. So over here, I could say this is roughly 116.6 degrees. That's what I have. So I can then see that my polar point here is given by my r, square root 45, and my angle, 116.6 degrees, at least roughly. If I wanted to write the precise angle, I would just have to leave it in this inverse cosine form. Now, of course, it's important to note that since this is a polar point, this isn't the only answer I could have come up with. I could add or subtract 360 degrees to my angle. I could go ahead and maybe add 180 degrees to have myself facing in the opposite direction, and then just change my r to negative. So it's very, very, very important to note here that, again, this is one of infinitely many answers. And all those answers would technically be correct. So hopefully this process of converting from polar to rectangular and vice versa isn't too terribly complicated, and with a little bit of practice you'll be able to get much better at it. In the next video we're going to start to take a look at some polar equations and how I could ultimately begin to convert those using a lot of the same ideas that we had just discussed.